Hello everyone, welcome back to the channel. In this video we are going to solve beam with an internal hinge. You can see there is a beam with the point load, with the uniformly distributed load, bending moment, and the internal hinge present at 6 feet. These all units are given in feet. So we are going to solve a beam with the internal hinge and obtain the shear force and bending moment diagram. For this, we are not using hand calculation. We'll be using software called Beam Guru. So this type of problem is very important for the structural analysis exam and the real design understanding. So let's start step by step. First, we will open Beam Guru. It's beamguru.com. You'll find the software online. You can find it in Google. Since we are calculating beam, we will open beam calculator online. Let's open it. We have to wait for some time since it is processing. So this is our problem. Here the beam has fixed support at one left end, roller support on the right end. You can see roller support over here, and internal hinge at point 6 feet from left end. So this is your internal hinge. The beam carries 20 kip point load, which is this one. It also carries 50 kip moment, which is at 4 feet from fixed end. We have a uniformly distributed load, which is 8 kip per feet, and it is starting from point 8 to all the way at the end. Now we will use Beam Guru to generate the shear force and beam bending moment diagram. Yeah, there it is. So this is the Beam Guru. We can solve our problem through the software. Here we can see the beam length is given in meter. Now we have to change, since our problem is in feet. Let's change this one to feet. So this is in meter. Now we can go here. You see meter. We can change this meter to feet. Okay, now we can do that. So how much is the total length? Our total length is 4, 6, 8, and this 6. So total will be 14 feet. Let's do it. 14. Okay, that's a 14 feet. We can write if you want. Okay, that's a 14 feet. Now you can see it's a 14 feet. You can see at the left end there is a fixed support. So let's give fixed support. Now we'll move towards support. So which is fixed support? This is fixed support. Okay, so fixed support is at the left end. You can see here. Let's add it. Next I'll define right support. Right support is the roller support. So let's go to roller support. Okay, this one is. Now here this is on our right side. We can click here right side, and this is position. So if we have to enter some position, We can click it here, and at what distance the support is situated, we can just point it out here. We can just write it down here. So in this case, we have on the right, just click it here. Now CC on the right, it's roller, and on left side, it's fixed support. So now we have to provide, yeah, okay, we have internal hinge at 6 feet from left. Okay, let's provide this internal hinge. Now, what is the position of internal hinge? It's a 6 feet from left. Okay, 6. Let's add it. Okay, you can see this is 6 feet from left support. Now, uh, there is no support that we need to assign here. Okay, now let's move uh, to the load. Let's go to the load section, and first we will apply point load, uh, which is 20 kips downward point load at the specified location. Let's see, this is the point load, and this point load is situated at 2 feet from left end. Okay, so the position will be 2 feet. Okay, since it is in 90-degree pointing downwards, so this 2 will be minus. Okay, over here. So this is our load magnitude, and it is 20 kilonewton. So this 20 kilonewton is upward. Now we have to provide minus so that it could come to negative directions. See, 20 kip, 20 kip over here. Now let's add it. So what's the next load we have? We have a hinge which is situated at 4 feet from left end. Uh, this is bending, this is moment. So let's provide moment at 4 feet. So this is the moment we have. What's the position? That's a 4 feet. And what's the magnitude over here? Magnitude is 50 kip feet. So this is 50 kip feet. And which direction? This is anti-clockwise, but we have clockwise direction over here. So let's see clockwise direction. Let's add it. Now what's the next load that we need to provide? That's 8 kip per feet. That is UDL, uniformly distributed load, which is starting from point 8 to all the way at the right end. This is the load, uniformly distributed load. Its starting position is point 6. Oh no, that's 8.8. So let's do 0.8, and position is 14. Okay, what's the magnitude? Magnitude is 8 kip per feet. Okay, so it's pointing towards upward, but we have pointing towards downward. So for that we have to provide minus. Okay, perfect. So let's compare with our problem. We can see we have load, point load, we have a moment, we have uniformly distributed load. Okay, I think we are all set here. Okay, now, okay, I think we are all set here. Let's analyze this part, how we can get bending moment using beam guru beam analysis software. Now if we calculate here, let's see, it's being analyzed. Okay, you just need to ignore this one. Okay, let's see, this is our shear force, and this one is the bending moment. Here, since this one is free version, we cannot get full report, but yeah, if we calculate the shear force and bending moment, it will be easy for us to solve the problem, and this is the quickest way to analyze any beam having different support. So just want to point out here that our bending moment, you see, it's 0 at internal hinge, and this fixed support develops a moment while uh, the roller support does not. So the bending moment at roller support is 0. You can see over here, and you can see the shear force varies linearly over here. In shear support, internal heat does not cause any kind of jump, so because shear can pass through a hinge, so that's why. But in bending moment, you can see the shear force bending moment will be 0 at the point of hinge, because the internal hinge makes the structure statically determinate, and it allows rotation but prevent moment transfer, which is why the bending moment is 0 at that point. And this understanding the behavior is very crucial for both exam and real structural design. So this is how we can analyze using beam guru to different beam with internal hinge. If you found this video helpful, please like this video and subscribe the channel, and thank you for watching. See you in the next video.